I'm Anil Kumar. Welcome to my series on trigonometry. In this video, I'm going to discuss with you some most important concepts. If you understand these concepts, you can actually do very well in trigonometry. We are going to understand the primary trigonometric ratios, sine, cosine, and tangent ratio. What is the cast rule? What are special triangles? How to evaluate trigonometric ratios, work with inverse trigonometric ratios, crack some multiple choice questions, and then conclude with best strategies and tricks to master. What you need? You only need to know that in a right triangle, as shown here, we'll be working with most of the time, that sum of squares of two sides, a square plus b square, is equal to c square, the Pythagorean theorem. Right, so that is the basic which you should know before we begin this unit on trigonometry. Right, so let's take up the very first thing, which is to understand primary trigonometric ratio. So here we have a right triangle ABC. At C we have the right triangle. Hypotenuse is lowercase c. That is how you label your triangle. Side opposite to A will be called lowercase a, and side opposite to B will be called lowercase b. That's a standard way. Primary trigonometric ratio. There are three primary trigonometric ratios. One is sine. And when we talk about angle, it's better to put some angle here. Let's say this angle is theta. Now if I don't write theta, I will write b, right? So that is also possible. So let's work with theta in general. So we use these most of the time Greek alphabets, alpha, beta, gamma, theta for angles. So if you're not using those angles, you have to use the vertex value. Now sine theta is a ratio which is opposite over hypotenuse. And then we have cosine theta, which is written in short as cos, cos theta, which is adjacent side over hypotenuse. And then we have tangent theta, which is written as tan in short, which is opposite over adjacent. So some of you must have noticed that the ratio of sine and cosine is tangent. So I could also write tan theta here as equal to sine theta over cosine theta. Now when we say opposite side, it means what? We have to look from this main angle, theta. So this side right across is treated as opposite side. Perfect. And the side which is adjacent means you're looking at the side between 90 degrees and the angle. So this side is called adjacent side, and that you know is hypotenuse, the longest side of your right triangle. Correct? So that is how we are going to relate all of them. A very easy way to remember this is by an acronym, SOHCAHTOA. So we could write this as some people write opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent, right? SOHCAHTOA. And some people also write like this: sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. Either way, it is the same thing. But some way or the other, you need to remember this, right? So follow the way which suits you best. Now here is the very first question for you. Find the value of tan theta if cos theta is 12 over 13. So work it out. You can pause the video, answer this, and then look into my suggestions. Now, since it's the very first video and the first question here, cos theta means what? Adjacent over hypotenuse. So we are saying this is 12 and this side is 13. Now if you apply the Pythagorean theorem, you can find what the other side is. So we can say, well, b square should be equal to 13 square minus 12 square, and b should be equal to, this is 169 minus 144 square root, right? And that is equal to square root of 25, which is 5, correct? So this side is 5. Now you know all the three sides, and you can say what is tan theta. Perfect. Tan theta is the ratio of opposite over adjacent. So in this particular case, we know tan theta should be what? Tan theta should be 5 over 12. Is that correct? So that is how you may be solving some of the questions based on the primary trigonometric ratios and the right triangle, correct? So if you understand this, most of the questions can be answered. Perfect. Now let's look into the second concept, and that is called the cast rule. So when we say cast rule, what does it mean? Well, in North America, we use this term. In other parts of the world, we may use something else. Since I learned the other way, right? So how I learned was all are positive here, right? So we're talking about the sign of, trig ratios, right? Whether they are positive or negative. So this is our quadrant 1, that is the quadrant 2. Here is quadrant 3, and then we have quadrant 4. All are positive, all trigonometric ratios are positive here. Sine is positive in quadrant 2, tan in 3, and cosine in 4. So the way I learned was, we are fond of tea, so we say all silver teacup. So that is the way we learned, right? So our way was, for this equivalent was all silver teacup, right? So that's how we learn. But here we say cast rule, right? That means cosine is positive in quadrant 4, all are positive in quadrant 1, sine in 2, and tan in 3. So inherently it has a problem, since we should normally start with 1, but you know, cos is here. So you have to get this orientation right any way you like. So what we're trying to say here is that we're working on these three things, right? So we are saying sine theta, cos theta, and tan theta, right? Now, as we just saw in the very first part, these are basic ratios of two sides in a particular right triangle, correct? So when we work with a coordinate system, we could take a point as xy, correct? So xy becomes our point, and the distance from the origin is r. R is always treated as positive, since r will be equal to square root of x square plus y square. Again, from Pythagorean theorem, you can figure it out. This is x for you, that is y for you. This is the right angle. So x square plus y square is r square, and r has to be square root of x square plus y square. It is a distance, so always positive. Perfect. Now, in our coordinate system, we have the x values and y values, which could be positive or negative, right? So the x and y values could be positive or negative. So now let's look into their sign. In quadrant 1, both are positive, right? X is positive, y is also positive. Here, however, x is negative, right? So we have a negative x value, but positive y value. In this quadrant, we have both negative values, and then we have a positive value for x, but a negative value of y in quadrant 4. Correct? Now, the ratio of sine and cosine, as you know, is simple. In this triangle, which we are looking into, where the sides are x, y, and r, let me redraw this triangle, right? That'll be better. So let me redraw this triangle here, slightly bigger. So if this point is O and P, right? Let's call this as point P with coordinates x and y. Then x is your horizontal distance, y is the vertical distance, r is this. Now if you are in quadrant 1, both are positive. These ratios of sine theta, cosine theta, and tan theta with respect to this triangle and the angle theta here is what? Let me write x here. It is y over r, right? So it is y over r. For cos, it is x over r. And for tan, it is y over x. Correct? Now, if you look into the signs, in quadrant 1, in quadrant 2, in quadrant 3, and in quadrant 4, what do you notice? Right, so you can make a table for yourself and see how these signs are changing, right? So, in the first case, when we talk about quadrant 1, everything is positive, right? So, it is positive over positive, right? So, all are positive, correct? So, obviously, you will get all of them as positive. But in quadrant 2, what really happens is that x value becomes negative. So x is negative, others are positive. So we have a ratio of positive over positive, but cosine becomes negative. Do you see that part? And what happens to tan? Again, x in the denominator, right? So it is divided by a negative. So that means sine remains positive, but these two becomes negative. In quadrant 3, what you notice, both are negative. So this is r is always so negative over positive, r is always positive, right? So x and y become negative. But for tan, both are negative. So a ratio of negative over negative gives you positive in quadrant 3. Sine and cosine remain negative. In quadrant 4, x is positive, right? So x is positive, r is always positive. Y is negative, r is positive. For y and x, y is negative and x is positive, and therefore cosine is positive, others are negative. Do you get the idea? So that is how you will get signs in different quadrants for trigonometric ratios. So I hope that helps, right? So now here is a question for you, question number 2, which says, given sine of 40 degrees, so 40 degrees will be somewhere here, equals to 0.6428, and sine of 50 degrees is 0.7660. Find the value of sine of 130 degrees. So 130 degrees, how do you get? So figure this out. Sine of 220 degrees, and what will be the value of sine of 310 degrees? Now, when I write a question here, it is for you to pause the video, answer the question, and then look into my suggestions. So based on this concept, let's try to figure it out. Okay, 130 degrees will be in quadrant 2, right? It is more than 90. Perfect, it is in quadrant 2. So that should be how much? Well, since it is in quadrant 2, and it is like 180 minus what? So we'll do some math here. This is not a straight question. We may have to go forward to understand this concept, but you could write this as 180 degrees minus what? 50, right? So if you take away 50 degrees, then it gives you 130 degrees. Now, since you are in this quadrant and your angle now is 50 degrees, your value will be that and positive. Correct? So this will be equal to 0.7660. Right? So I just calculated this value for you. This concept is still not explained. Okay. Anyway, we'll again take this question later. Now let's look into the second one, 220 degrees. Now for sine 220 degrees, you land up here in quadrant 3. So let's see that. So it is in quadrant 3, right? So we expect a negative value. So we'll just close ourselves to negative value at present. But when you learn more, you will understand 220 could be written as 180 plus what? Well, 180 plus 40 degrees. So the value of 40 degrees is that much. So we'll get negative of 0.6428. Okay. But from this knowledge, you can at least give the sign. Sine of 310 means you are in quadrant 4. So it has to be a negative value. And to figure out how much negative it is, 360 minus 50, right? So this is basically 360 degrees minus 50 degrees. So we'll look into this answer and we'll get negative 0.7660. So that is how you could get the values. Anyway, from the cost rule, you could get the sine, right? So that is important. And from the next rule, which we'll learn soon, you'll get the value also. But I hope you understood what the cost rule is. So in quadrant 1, all are positive. In 2, sine is positive. 3, tan is positive. And cosine is positive in quadrant 4. Perfect. So with that, let's move on to the next concept. Now we are going to talk about some special triangles. These special triangles help us to provide value of trigonometric ratios. So one of the special triangle is 45 degrees triangle, where the two sides will be 45, one will be 90, of course, right? Since the sum is 180 degrees. The other one, we call it 30, 60, 90. So 30 degrees, 60 degrees, and 90 degrees triangle. Right? So let us sketch these triangles and then see how they help us to find the values for trigonometric ratios. In 45 degrees triangle, two sides are equal, right? So we have a right triangle here, and let's say 1 and 1 are the sides of the triangle, then hypotenuse should be square root of 2. How do I get that? I get that value as 1 square plus 1 square square root. 1 plus 1 square root 2. Correct? So that becomes our special triangle, which is treated as 45 degrees, 90 degrees, 45 degrees. Now, looking at the side from 45 degrees, what is sine of 45 degrees? Sine of 45 degrees will be opposite over hypotenuse, which is 1 over square root 2. And what is cos of 45 degrees? Well, cos of 45 degrees is 1 over square root 2, which is adjacent over hypotenuse. And what is tan of 45 degrees? Well, the tan of 45 degrees is ratio of 1 over 1, that gives you 1. Clear? So remember how we got these ratios? So sine, we are saying, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tan is opposite over adjacent, right? So remember SOHCAHTOA. Now, the next triangle for us is 30, 60, 90. So 30, 60, 90 we actually get from equilateral triangle. So let me first sketch equilateral triangle where all sides are equal. Let us say that these sides are of length 2 each. Now, let me drop a perpendicular from one of the vertex to the opposite side. So that will cut it into 2 equal parts. Then we'll get half of this as 1, and this side will be square root of 3. How do I get that? Well, I get that as 2 square minus 1 square square root, which is equal to square root of 4 minus 1, which is equal to square root of 3. Pythagorean theorem. So basic is you should know Pythagorean theorem, and you should be very good at working with these radicals, right? So that is another important thing to understand. Now, this angle is how much? Well, this angle is 60 degrees, and then we have a 90 degrees. Since we have a perpendicular, what is that angle? Well, that should be 30 degrees. So that means in one triangle, we have 30, 60, 90. Now this is a very, very useful triangle, which will give us values for sine of 30 degrees, cos of 30 degrees, tan of 30 degrees, also sine of 60 degrees, cos of 60 degrees, and tan of 60 degrees. Does it make sense to you? I would like you to pause the video here and now fill up these costs. Fill up these ratios. Well, for sine of 30 degrees, you have to look from that side. Opposite side is 1, so it is ratio of 1 over 2. For cos of 30 degrees, adjacent is square root of 3. You get square root of 3 over 2, and for tan, it is going to be 1 over square root 3. Is that clear to you? So that is how we find them. Now, for sine of 60, I have to look from that side. So 60 opposite is square root 3. So we get square root 3 over 2. Perfect. And for cosine, 1 over 2. For tan, it is going to be, for 60, square root 3 over 1. That is what it is. So I hope you have got it right. Perfect. Now, it's a time to just relax a bit and observe what we are looking at. Now, this is the most important part. Now, what you notice here is sine of 30 is half, cos of 60 is half. So they are equal. Do you see this? Sine of 30 is half, cos of 60 is half. They are equal. Can you explain me why? Tell me why. Now, from here, we get to the next level. Why is it so? So if you look from here, if I'm saying sine of 30, I'm saying that is the opposite side and this is the hypotenuse. But from cos angle 60, it becomes adjacent. Do you see? So it becomes the same value. And you also notice that as far as 30 and 60 for cosine and sine is concerned, these are also equal. So cos of 30 degrees means square root 3 over 2 adjacent side, but for 60 sine it becomes opposite side, so they have to be equal. So this important property is called cofunction identity. Correct? So in any right triangle, what we have is that cos of 90 degrees minus theta is equal to sine of theta. Do you get the idea? It works both ways. That is to say, sine of 90 degrees minus theta is equals to cos theta. Perfect. So make a note of this. Very, very important identity. Correct? So in this part, we have learned how to get exact values of our trigonometric ratios, right? So that is what we learned here. So we found the exact values of our trigonometric ratios. So we also say these are the exact values. Perfect. Now there are critical values which we have really missed, and I'm going to use the graph of sine and cosine to show you those critical values. The critical values are, when are these functions 0 or 1, right? So that is critical. Sine graph is kind of like this. And the cosine graph is kind of like this, where the maximum value could be 1, the minimum value could be -1. For cos, it is the same thing, 1 and -1. However, the places are different, shifted by 90 degrees. So for sine, it is 0 at 0, and this is 180 degrees, and this is 360 degrees. Correct? They are zeros. For cos, the zeros are at 90 degrees and at 270 degrees. So these are the zeros. You get the idea? These are the zeros. Now what are the maximums? So the maximum value is the value at 90 degrees and the value is 1. The minimum value for sine is at 270 degrees and is -1. Is that clear to you? As far as cosine is concerned, the maximum value is at 0. So this maximum value is at 0 and the value is 1. The minimum value is at 180. And it is -1. Do you see that? And the maximum also happens at 360 degrees. Do you get this? So that is another very important thing which we've tried to figure out from the graph. So if you are working with sine and cosine and tangent ratios, for zeros and ones, you should look into these graphs, sketch them, get a clear idea. Perfect. I hope that makes sense. You'll talk about tan. Well, tan is the ratio of sine and cosine. So then we should think about like this. Tan theta is sine theta over cos theta. So when is tan 0? Whenever sine is 0. Is that okay? That is how you'll figure it out. And when is tan 1? When both are same, which is for 45 degrees. We already have this value. Perfect. Now with this in mind, there are 3 questions for you. Write exact value of each of the following. Sine 60 degrees, cos 45 degrees, tan 150 degrees. Now these two are in quadrant 1, they should be positive. 150 degrees is in quadrant 2. You need to figure out for tan, should it be positive or negative. You could use the cos rule. Correct? Now let's take a small break here. Watch the wilderness close to our area here in Canada, and then we'll continue from the next topic. I hope. They'll fly now. I hope you enjoyed the break. It is really refreshing. And now with the fresh mind, let us bring everything which we have learned to solve some questions. Now question number 4 here is to evaluate trigonometric expressions. So we have given you 4 trigonometric expressions here. I would like you to pause the video, write their answer, and then look into my suggestions. Now how should we find or evaluate these expressions? We have to keep 2 things in mind. One, we learned about the cast rule, that is to say that we know that is how these ratios are. All are positive in quadrant 1, sine in 2, tan in 3 and cosine in 4. Perfect. You will see different numbers here and these degrees means you are in different quadrant. So you have to figure out that the value should be what? Positive or negative. That is one thing. Second thing which you need to remember is your triangles. The special triangle, right? So we have worked with 2 triangles which gives us all the required angles. The 45 degree one gives you 1 square root 2, right? This is 45 degrees one. So I hope you remember this 30, 60, 90. This angle is 60 degrees, right? The sides are, this side is 2, this is half of 2, and that is square root of 3, okay? Now these are your triangles to work with, and also for 0 degrees you can always look into the graph. We don't have 0 degree here, so we'll just focus on these 2 triangles and the cast rule. Perfect. Sine of minus 30 degrees. Now when you're looking into this, let me make a bigger view of understanding how do we get the values, right? So we'll concentrate here. So when I say sine of minus 30, that means we are here, right? So that is minus 30. So when you move clockwise, that becomes minus 30. So you are in quadrant 4. Since you are in quadrant 4, sine value is negative. Do you get the idea? You are in quadrant 4, only cosine is positive, sine is negative. And now for 30 degrees, what is the value of sine? You look into this triangle, that is 30 degrees for us. Sine is opposite over hypotenuse, so it is half. Clear? So you get the sine value. Now, let's look into the cosine 60 value. Cosine 60 means you are in quadrant 1, it has to be a positive value, right? So we'll just put this in the bracket, it's a positive value. For 60 degrees, we'll again look into this adjacent over hypotenuse 1 over 2. So this is also half. Correct? Now let's look into the third value, which is tan of 210. Now when I say tan of 210, it is more than 180. How much more? 30 more, right? So this is tan of 210. So 210 really means 180 plus 30, correct? So that means we have to look into the acute angle 30, right? Because this angle is same as that triangle. Now tan, as you can see, is positive, so it's a positive value. And for 30 degrees, you have to look from this side, that is 30. Opposite side is 1, adjacent is square root 3. So this is 1 over square root 3. Does it make sense to you? So that is how we are going to evaluate product of these 3 trigonometric ratios for the given angles. Is that clear? What did we use? We used the cast rule to get the sine and special triangles to get the values, and these are the acute angles. So look into the related acute angles. So related means for 210 you saw we are checking with respect to horizontal. So related with horizontal line. So related with this line, horizontal line. Is that okay? So all the angles will be measured related to the horizontal line. Okay. Now when you multiply these things, you get a negative sign for sure. 2 positive and 1 negative. And what you get here is 1 over 4 square root of 3. You may be required to rationalize this, right? So if you rationalize this, you get negative square root 3 over 12. So multiplying divide by square root 3. Is that okay? So that is how you actually get the value. Now, let's take another example. Those two will be your test questions. So let's again look into this. So we'll apply the cost rule. So for the very first one, sine of 135, we are in this quadrant, right? Now that is 135. So that is how much? Which is 90 plus 45 is 135. Clear? 45 means we have to look into this triangle, and quadrant 2 means sine is positive. So sine is positive, 45 degrees, value is 1 over square root of 2. Clear? Now, for cos of 210 degrees, 210 degrees means you are here, which means it is 180 plus 30 to give you 210 degrees. So we have to look into this angle 30 degrees for cosine, but we are in quadrant 3 this time. In quadrant 3, cosine is negative, right? And for 30 degrees, cosine is square root 3 over 2. Now let's look into the tan ratio. Tan 60 degrees. So 60 is in quadrant 1, it has to be positive. And for 60 degrees, tan is opposite over adjacent, so it's square root of 3. Now you get your thing, right? So just multiply and get your result. 1 negative, 2 positives means negative result. Square root 3 times square root 3 is 3. And here you get 2 times square root 2 in the denominator. So if you rationalize it, then what do you get? You get 3 square root 2. And when you multiply by square root 2, it becomes 2. And you get 4 here as your answer. So I hope that is understandable. So we basically multiplied by square root 2 and divide by square root 2 to get the answer. Just as we did here, right? To get the answer, right? So that is how you're going to do. I hope the steps are absolutely clear. So look into part C and D and do it yourselves. So the steps involved are, you have to first look into 330 means what? It is like this. This is 330. So basically it is 360 minus 30 degrees. You are looking into 30 degrees triangle. When you say 210, in that case you are looking into this triangle, which is 180 plus 30 degrees. And when you say 135, you are looking into this triangle, which is, you can say 90 plus, or I will prefer to write this as 180 minus 45 degrees, right? So we are looking always into these acute angles. And on top of it, you're going to apply the cost rule, where what is positive and what is negative. So in this case, tan is negative, cos is negative, and sine is also negative. All three are negative. So you expect a negative answer. You get the idea. That is how you're going to do it. Perfect. So the last one, I'm not giving you any help. So look into that solution. Post your answers in the comments. And now let's look into the next part of it. Question number 5. We'll now work with inverse trigonometric ratios. That is to say, we'll give you the value of trigonometric ratio. You have to find the angle. That means basically find angle given value of trig ratio. So that is the kind of question now we are going to look. Now the very first one is, well, let's read this. Solve for x, where x is between 0 to 360 degrees. That means we'll just focus on one circle, right? So that is what we are trying to focus on. The very first question is sin x is square root 3 over 2. So square root 3 over 2, we know it is positive. Let's write down our rule. So in this particular case, we'll make a small thing here itself. It will help. When we say positive, we are looking for two answers, one in quadrant 1 and the other one in quadrant 2, since sine is positive in quadrant 1 and 2. Does make sense to you? Second, we have to look for our special triangles. So we have two special triangles. One is the 45 degrees one, the other one is 30, 60, 90. So it's a good idea to draw them, especially when we are beginning to learn all this, correct? And this one will be 2, 1 square root 3. This angle is 60 degrees, this angle is 45 degrees. So when I say sine x is square root 3 over 2, square root 3 over 2, that is the 1. But how do I relate sine, cosine and tan? Well, we learn SOHCAHTOA. Sine is ratio of opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. So sine is square root 3. We are looking for opposite, so we are looking from here, right? So angle 60 degrees. So we get this as 60 degrees as our answer. So what should be this angle? Well, that angle has to be 180 minus 60. Do you see that? So from here we get our x as 60 degrees and 180 minus 60, which is 120 degrees. Do you get the idea? So we get two solutions since sine is positive in two places, one in quadrant 1, the other one in quadrant 2. Perfect. That is how we are going to answer. Now let's look into the second one. Cos of minus square root 3 over 2 minus cos means we are looking into these two quadrants. Cos is negative in these two quadrants, it is positive in quadrant 1 and 4. Again, the value square root 3 over 2. Square root 3 over 2, but cos is adjacent over hypotenuse. So adjacent to square root 3 is this side, so we have to look into that angle, which is 30 degrees. So we get an angle of 30 degrees here. Okay, but that is not the right answer. I am going to look into this place. Oh my God. So this should be not x, we call this as alpha, a related acute angle. So I want to take a moment here to really describe the word related acute angle since I missed it right in the beginning. So that is the angle which is like always considered in quadrant 1 with the horizontal that gives you the base value of square root 3 over 2. Now we know that this angle with the horizontal is same. We have to always report the principal angle. So the angle which we give is basically the principal angle. So that is the angle which we need to report. How much is that? Well, in this case, it is 180 degrees plus and minus 30 degrees. So we get two answers here. One is 150 degrees, the other one is 210 degrees. Does it make sense to you? So whenever we are looking for the answers of angles in our domain, which is from 0 to 360 degrees, we expect two solutions. How do we get them? First, we'll find the related acute angle with reference to our special triangles. Then, we'll try to see in which quadrant the answers are, and then we'll adjust our values with the horizontal 180 degrees. Is that clear? Okay. Let me take one more example, and the last question will be for you to verify your results. Okay. Tan x equals to 1 over square root 3. Tan is positive where? Tan is positive in two quadrants, which are in quadrant 1 and 3. So that is where it is positive. Now here, one angle, 1 over square root 3, 1 over. Tan ratio, is opposite over. So we're looking for opposite over adjacent, right? So we need adjacent side to be square root 3, opposite to be 1. So it's 30 degrees angle, right? 30 degrees. So we get our acute angle of 30 degrees. How much should this be? 180 plus 30, right? So we get 180 plus 30 degrees, which is 210 degrees. Do you see that? So we get our solution for this as 30 degrees and 210 degrees. Is that clear? Perfect. So finally, let's report the answers here for 60 and 120 for the first case. For cos, we got 150 and 210 degrees. For tan, we got 30 and 210 degrees. The last one is for you. 1 over square root 2. You look into this triangle, 1 over square root 2. Minus means you look into solution in these two quadrants. Report your angle. 180 plus and 360 minus the angle. Perfect. So now let's look into the multiple choice questions. Some of them can be very tricky. However, you know all the tricks now, so apply them and write the solutions. So I'd like you to pause the video here, answer these 3 questions, and then look into my suggestions. The very first question is, if sin x is 0.25, then cos of 90 minus x is what? So you remember the cofunction identity which we learned? It is based on this. So it is based on cofunction. So if you are looking at any angle x, this is 90, the other angle will be 90 minus x. You get the idea. So if sin x is 0.25, cos of 90 minus x will also be 0.25. They are same, correct? So in a second, you can actually answer the question, and that is where multiple choice question answering becomes important, right? So once you know the concepts learned, this question can be answered within a second. Question 7. How many solutions will the equation of sin x cos x equals to 0 have for x between 0 to 360? So I showed you with the help of a graph how many zeros will they have, right? So that means either sine could be 0 or cosine could be 0, right? So how many zeros do we see? Their product has 3 for sine and 2 for cosine, so option C. Do you see how easy it becomes? We are multiplying 2 numbers to get 0. Either one of them could be 0, so we get 5 solutions. Does make sense? Within a second. Question number 8. Tan x is 0.75. What could be cos x? Now this could be tricky. Now when I say tan x is 0.75, think about 0.75 as 3 over 4, right? Because we are talking about ratios. So always convert to ratio. So that is a trick. So ratio, right? Always look into it as a ratio. So when I say tan is 3 over 5, we know tan is opposite over adjacent, right? So what we have here is a triangle where one side is 3, the other side is 4. So that is what tan x is. Do you see that? Is that clear to you? So it's a right angle triangle, the other side hypotenuse should be 5. So you are saying what is cos? And you know cos should be adjacent over hypotenuse. So you expect a value of 4 over 5. Right. But 4 over 5, which is equals to 0.8, is not there. But there is minus 0.8. Could this be your answer? Think about it. Cos is positive in 2 quadrants. So there could be a value here also. Perfect. And here, when you apply the cos rule, tan is positive, cosine is negative, so that is the correct answer. Do you see that? So it's a tricky question that may require about a minute to think. So there are a wide variety of questions which you will be seeing in multiple choice test papers, but you will soon realize that all of them can be answered with what we have learned in this video. So it was worth spending half an hour, okay? Now let's get back to the strategies which we have learned. So a couple of strategies which we learned. Very important is the cofunction identity, right? So let's write it down. The cofunction identity is that cos of 90 minus theta is equal to sine theta. Sine of 90 minus theta equals to cos theta. So we didn't go to trigonometric reciprocal ratios, but at this stage we could talk about it. We can say this is cotangent theta. So at reciprocal ratios are 1 over that, right? So we just introduced them. Another thing which is very, very important for us to know is the trigonometric Pythagorean ratios, right? So I'll conclude with that. So let's say we have this triangle with angle theta, the sides, we are saying A, B, and C, right? So in this case, you know the Pythagorean theorem, which is A square plus B square is equal to C square. Perfect. Now I could divide each side by C square. So I get A square plus B square equals to C square. Dividing them all by c square, what do I get? I get a over c whole square plus b over c whole square equals to 1. Now I have converted this into a ratio a over c. A over c with respect to theta is what? A is opposite side, right? So this is my opposite side. This is adjacent side, that is hypotenuse. And we remember, very important, is SOHCAHTOA. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tan is opposite over adjacent side. So A over C is sine theta. So we get sine square theta plus B over C, which is cosine theta. Cos square theta equals to 1. And this is one of the most important identities for trigonometry. We call it Pythagorean trigonometric identity. So this is what you need to learn as a trick or a tool or a formula or an identity to do rest of the questions. So then let's move on. Question number 9. Exact value of sine square 50 plus cos square 50 times tan square 45 is what? Well, we just learned this is 1 and tan 45 is also 1. So 1 times 1 should be 1. Do you see that? And question number 10 is the last one here, which is, which of the following is true? Cos of 90 degrees minus x is greater than x or less than x or equal to x. Of course it is equal. It is called the cofunction identity. So I think it's a good time to close this video. In the next video, we'll talk about the reciprocal or the 1 over trigonometric ratios. We call them secondary trigonometric ratios. Perfect. But as far as the primary trigonometric ratios are concerned, we have learned how to figure them out, how to work with them, and even how to solve or evaluate some expressions. I hope that helps. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.